Hi everyone. So for this problem we're finding this integral, but before we start I have to say that I cannot stand that they tell you to not include plus c in your answer. Including plus c is really important. It shows that you're finding the most general form of the antiderivative, but I suppose that when you're doing your online homework you're going to have to follow their directions. But when you're doing your written homework or your exam, please make sure that you are including that plus c. So I'm going to start by rewriting this integral, and you don't have to show all these steps, but since this is the first one, I kind of want to show each step. So we can break this up as x to the fourth dx plus 3 times the integral of x squared dx plus the integral of 1 dx plus 2 integral of e to the x dx. So I'm just using all the properties of integration here. So I'm going to use the power rule, and we're going to increase the power by 1 and divide by the new power. So we will get x to the fifth, and then we're going to divide by the new power. I'm going to keep doing that for each one. So here we have a 3. When I increase this to an x cubed, I'm going to then divide by the new power. For the integral of a constant, you kind of technically have a 1x to the 0 power here. So we're increasing this to an x to the first, and then we're dividing by 1, which obviously we don't have to do. And now for this last one, remember that the derivative of e to the x is e to the x, so the integral of e to the x is e to the x. So we'll have 2 e to the x and then plus c. Just to clean this up really quickly, we will have this. Now I showed a lot of extra work. I would be fine with you going straight to this answer.